Hello everyone, this video is a follow-up to the video on playing notes, so hopefully at this point most of what's on the screen here should be familiar to you. We start by importing everything from the SCAMP library, then we create a session object called S. Remember that the role of a session is threefold. It's to manage the flow of time, to act as an ensemble that holds all of the instruments, and also to act as a transcriber that can later generate music notation. Then after that, in this line, we ask the session to create a new part. In this case, I made it a brass sound. And we ask it to play a bunch of notes. And remember, the play note call goes pitch, volume, duration. Now, I've also added one more function that's not familiar from the previous video, which is just the wait function. But even though it's not familiar, it's probably pretty self-explanatory. It just waits for the given length of time. So I'll stop beating around the bush and play this for you. So obviously this sounds pretty great, although somehow I feel like I've heard it before, but beats me where that could have been. But here's the thing, what if I wanted this to play twice, or 3 times, or something like that? Well, we've already seen one way of doing that, which is to use a loop, and we could do that here. We could say, while true, and indent this whole block, and then, oops, not the while true, and then it'll play it over and over. We could even play it a certain number of times by introducing a counter, or by using this somewhat awkward syntax, which you may see at some point if you do more Python. Here we have a for range loop, but instead of putting a variable name here, a traditional variable name, I just put an underscore. And when we say range 3, what this really means is range 0 to 3. The underscore here is just meant to indicate that I'm not going to use this variable at all. And in fact, this is just a kind of awkward but efficient way of saying do this 3 times. But sometimes loops can be frustratingly inflexible. For instance, what if we want to play this twice, then play one long, loud, low note, and then play it again? Well, we can reduce this 3 to a 2, and we can add a low note here. Not indented, right? Because if it's indented, it's part of the loop. When we stop indenting, it means that's the end of the loop. And I'll give this a low pitch and make it last for a while. But then to get it to play one more time, I actually have to take all of this code and copy and paste it again. So this works, but it's obviously not ideal. And in general, one of the basic principles of programming is that you should try to repeat yourself as little as possible. What we want is some simple and efficient way of making this whole block of code happen anytime we want it to. And there's a way to do this. It's called a function. Now there's 2 steps to using functions. The first one is defining the function, and the second one is calling the function. To define the function, we use the following syntax. We would say def for define, and then you give the name of the function. In this case, for some reason, I think I might call it beat it. Then open and close parentheses and a colon. This groups these lines of code together under the name beat it. Now, if I just delete all the rest of this and hit play, nothing happens. Because all we did is define the function. We didn't actually ever make it happen. We never called the function. Now we've actually seen already how to call a function. All of these are function calls. Play note is a function call. Wait is a function call. New part is a function call. It always looks like the name of the function followed by parentheses, sometimes with extra information called arguments inside of the parentheses. In this case, there are no arguments, and actually we can define the function to have arguments by putting extra information inside here. But we'll do that later. All we need to do now to call this function is type beat it, open and close parentheses. Notice that this line is not indented, because if it were indented, it would still be part of the definition of the function. Let's take a listen. Now to do it twice, all we have to do is copy and paste this line. This calls the function once, and then calls it again. But this is way more flexible than a loop, because if we want to do a low note in between, all we have to do is copy and paste it like so. Change the length a little bit here, and let's take a listen. A really natural time to use functions in music programming is to define a gesture. And actually, you could argue that this function has two different gestures in it. So what I'm going to do is separate it into two separate functions. We'll have the opening arpeggio and label that beat it 1. And then the end of the phrase we'll separate out into a separate function called beat it 2. This is great because we can treat the melody modularly now. We could start with the second half, play a low note, and then play the first half, then play the second half, then play the second half again. It may not be especially musical, but let's take a listen to it. Now, if we want to go back to being able to play the whole melody with one simple function call, we can actually write a function that puts those two function calls together, like this. Def, beat it full. And the first line is going to call beat it 1. And the second line is going to call beat it 2. So now down here where we actually play the first half and then the second half, we can replace this with beat. And remember tab completion, I can press tab and select beat it full. And for good measure, let's take a listen again. One of the super useful things about functions in SCAMP is that they can allow us to play multiple things at the same time. So I've already started to make this example a little bit more interesting. I added a second part with a trumpet sound and stored it in the variable trumpet. And down here at the bottom, I defined a function called top part in which the trumpet plays some notes. Finally, at the end, I call the top part function so that we can hear what it sounds like. Let's take a listen. So sounds good. Sounds like it'll probably go really well with the other part. Let's see what it sounds like. Okay, so it seems like there's a problem, huh? Things don't naturally happen at the same time. By default, a programming language like Python is sequential. So if you write beat it and then you write top part, it's going to run the beat it function and then it's going to write the top part function. If we want them to happen at the same time, the traditional solution in Python is to use something called threads. But there are certain issues with threads. Sometimes they'll tend to drift apart from one another. So SCAMP has its own way of doing this, which is more solid and more flexible, which is called forking. So instead of calling beat it, what we can write is fork beat it. Now notice I deleted the open and close parentheses after beat it here. That's because we're not calling beat it in a traditional sense. We're calling the function fork and passing the function beat it to the function fork. We're saying, here's this function I created it called beat it. Can you fork it for me? And actually, remember how I said that the session manages the flow of time? When we call fork here, this is a shortcut for writing s.fork. It's really the session s which is being asked to fork the beat it function. What this is going to do is it's going to start beat it as a parallel time stream that runs alongside the main script. I actually created a diagram back here to explain it. Here's the main script, the main process running along from left to right. And then here's the point where we fork beat it. It kind of starts its own parallel sense of time moving forward. Hopefully this diagram also explains why we might call it forking. I borrowed this language from Super Collider, and also from Chuck, which for some reason calls it sporking. Anyway, let's take a listen to what we have. Notice that actually the beat it function is shorter than the talk part, so it ends early. It's important to note here that the script is going to last as long as the main process lasts. So if we actually reverse this, we forked the talk part and then called beat it in the traditional way, this is what happens. And it actually ends here and ends up leaving a note hanging in the top part. The script ended when the beat it function ended, and we're left with one of these notes dangling. Now, if this asymmetry bothers you a little bit, that you're forking one part and calling the other one, even though you really just want the two to be parallel processes, you can actually take a slightly different approach, which is to fork both of them. So here we'll fork beat it as well. And now if we run the script like this, they get to start the first note, but then the script immediately ends. However, we can keep the script alive by calling s.waitForever. If we were going to look at this on the diagram, it would look something like this. We have two separate forked processes, both of which end at some point. And the main process is just going to keep going forever. Let's take a listen to that. But one thing that you'll notice down here, it never says that the script finishes. In fact, it's still running, which is maybe not ideal. A solution to this is to change this to wait for children to finish. If we run this script, we see that it ended. And what this effectively does is it makes the main process end right here when all of its child processes are finished. So that's the basics of using functions and making multiple things happen at once in SCAMP. Stay tuned for a few more advanced possibilities. Okay, now for a few more advanced things. So far we've seen that functions can be used to organize blocks of code, but it's really when you start using arguments that functions become a lot more powerful, both in programming in general and also in this musical context. So to demonstrate this, we'll go back to the main beat it gesture. And you might look at this and notice that most of the notes are short, 0.25 seconds long. There's one kind of medium-length note, and there's a couple long durations, both a note and a wait call. So what I'd like to be able to do is change up what these values are every time I call the function. The way that we do this is to introduce an argument. So we might introduce the first argument short length and replace all of the short notes with short length. And then we might make a second argument called medium length and replace the 0.5 with medium length. And a third argument called, well, long length is a little redundant, but we'll do it anyway. And replace the 0.75s with long length. Now, if we try to run it, Python complains that beat it is missing 3 required positional arguments. So what it's saying is that when we call beat it now, we're supposed to give it 3 numbers, one for the short length, one for the medium length, and one for the long length. So let's try that. Let's make the short length 0.1, the medium length be 0.5, and how the long length, let's make it 2.0, a super long note. Let's listen to it. So this is great. The exact same code now is so much more flexible, and we can actually get back exactly what we had before if we just set them to 0.25, 0.5, and 0.75. Now, if you're wondering how this works with forking, then I like your spirit. Let's take a look at that. So instead of saying beat it, instead of calling it the traditional way, we will say fork. And now remember, we can't use this open close parentheses because that's the way of calling the function normally. Instead, what we do is we type args equals, and then give it this list. It can be square brackets or regular parentheses. It doesn't really matter. One is a list, one is a tuple, and while that's maybe an important distinction in Python, it's not that important right now. And of course, if all we do is fork it, the program will end right away. So we'd better say s.wait forever. Remember, this could be s.fork as well. More on that distinction in a moment. But let's take a listen. Now that may not seem very different, but it gets much more interesting when we start doing this. So here I'm going to play several versions at the same time, but with different values for the durations. And this third one, I'm actually going to make the long notes short and the short notes long. Let's take a listen to this. Okay, so I found that a little bit muddy because they were all in the same octave. So let's add one more argument, transposition, and add it to each of the pitches. Now, since we've added a fourth argument, we'd better give it a value when we fork the function. I'll put one of them 1 octave up and one of them 2 octaves up. And let's take a listen. Okay, so now that we're doing that, let's make things extra interesting. I'm going to import the random module up here. This is a library that gives you lots of useful functions relating to random numbers. I'm going to restructure the code down here. For the transposition argument, I'm going to randomly choose from a list of numbers. So random.choice 0, 12, 24, 36. And for each of these durations, I'm going to pick a random number within the range 0.05 to 2. And you can do this with random.uniform. This uses what's called a uniform distribution, so that every number in between 0.05 and 2 is equally likely to be chosen. So I'm going to make each of these lengths a randomly selected number. And just to test it out, let's run the program here one time. So you can see it comes up with a different thing each time. So instead of just forking it once and waiting forever, what I'm going to do is put this in a while true loop. And continually fork new copies of the beat it gesture, and then wait another random duration. We'll maybe use the same random duration as before. So because we have a wait call inside of a while true loop, the main script will keep on going, and it'll keep on forking new copies of the beat it gesture, with each one having a random transposition and random lengths for the different notes. Let's take a listen. Well, that was glorious. Now, one of the most powerful things about forking functions in SCAMP is that each function can have its own independently controlled tempo. And to understand this, let's first clarify why it's the same thing to write wait2 and s.wait2. What's going on here is that s is a session, but a session is a clock. So if we go down here to the SCAMP documentation and type in session, and click on the session class, we see that the session object inherits from the clock object. And we see in the description here that this is a recursively nestable clock class, which can fork child clocks, which can in turn fork their own child clocks. Needless to say, things can get pretty complicated. But if we go back up here and ask Python to print isInstance s clock, this asks whether s, the session object, is actually also a clock. If we print this, it prints true. A session is a clock. Now, waiting is something that only a clock can do in SCAMP. This is why we can type s.wait. However, if you call wait on its own, SCAMP will look to see which clock is currently active and ask that clock to wait. Under the hood, what it's doing is calling this function, current clock. If we print the current clock here, it tells us that it's the session, s. However, if we were to print the current clock before creating the session, it tells us there is no current clock. So effectively what wait is doing is calling current clock.wait. So now you might ask what's going on if we define a function and fork that. So we'll define a child process here and print the current clock. And then we'll fork that child process fork, again, is the same as s.fork, because under the hood it's looking for the current clock, which is the session. And I'll add a wait call at the end here just to make sure that things don't end early. And if we run this, it tells us that the current clock running at this point is an unnamed clock that belongs to this child process. Okay, so this is all rather abstract. Let's make it a little bit more concrete by going back to one of the scripts that we played with earlier. So here we have the beat it lick and the top part, and we're forking the top part while playing the beat it lick. Since I don't want it to only play this once, I'll wrap it in a while true. Now if we play it, that sounds pretty familiar. But what's neat about this is that this top part can actually have its own tempo. I can get the current clock, and change its tempo to, say, 120. Let's take a listen to that. In fact, I can change its tempo partway through. We could make the second half go much slower. If all you want to do is just set the overall tempo of the child clock, there's actually an easier way of doing that, which is to use the initial tempo argument here. The result's the same. Now, an interesting but kind of mind-bending point is that the tempo of a child process is affected by the tempo of the parent process. So if I go here and I change the tempo of the session to 120, or s.tempo equals 120, then the overall part goes twice as fast, and the forked part will go twice as fast within the context of going twice as fast. This sounds like this. Anyway, needless to say, you can have quite a lot of fun with this. One thing that you could do again is use the random library and have it so that each time it plays the beat it lick, you fork the top part with a random initial tempo. That might sound like this. Well, maybe that didn't sound as interesting as I'd hoped, but I think you can probably make something pretty interesting with it if you try. Anyway, that's almost certainly more than you ever wanted to know about forking functions in SCAMP, and I hope you managed to come up with something creative. Thanks.